I'm trying to get you to see how a population and a sample are related. So again, population is the big picture. So I know this says 0 to 32. I don't even know if you can see those numbers. You guys never even took the let's just change it. This is 300 on the SAT. This is 1600 on the SAT. So the middle is 1,000. So I think 400 is actually the lowest you can get. So that'd be 600. Yeah, that makes sense. So it's 600 each way. So this might represent like the scores from last year. So it's really hard to get a 400. It's pretty common to get 1,000 or like a 900 or 1,100. It's really hard to get a 60. You know what I mean? So like this is representative of like there's not many people that got this score. A ton of people got this score. A ton of people got this score. Not very many people got this score. That's like all juniors from last year, let's say. Well, I don't have time to go around and ask all the juniors. Let's pretend. I don't have the data. I don't have the time. What I want to do is take a sample of, say, 10 of them and see if I can use that sample to guess the average SAT score. So I don't know this. We're kind of saying I don't know this. Because if I did know this, I wouldn't ever bother taking a sample. So I'm using this in a situation where, like, I don't have access to all the data. So we're pretending I don't have access to all the junior scores. So what I'm going to do, and I'll show you this animated thing in a second, is I'm going to take a random sample of 10 people, and I'm going to find their average. If I take another sample of 10 people and find their average, would it be the same? Probably not, right? Could be 10 totally different people. Take another random sample of 10, find their average. Probably still different. And I'm going to start looking at those averages, and those averages will make a graph. Will that graph, and I want you to think about it before I do it, what do you think that graph will look like? Will it be biased, unbiased, high variability, low variability? So just take a second and think. I mean, that's a hard question, especially not having seen it before. But do you think it'd be biased or unbiased? Like, do you think the average of my averages will come out to around 1,000? Do you think it'll be higher variable or low variable? Like, will it be more spread out than that or less spread out? So that's what I want you to know. What's up? Oh, I thought you said something. Okay, so let me do one. I'll start talking through what's going on here. So I'm taking a sample of 10. So that's the 10 scores that I randomly selected. Is that cool? And then this is the average of those 10 scores. Alright, so then I'm going to do it again. It's going to randomly sample 10 probably totally different people, find their average, and drop it down here. 10 totally different people again, and drop it down here. This is the one I want you to try to guess. So do you think this distribution down here will be unbiased or biased? Should be unbiased. Higher variability than this? Like more spread out or less spread out? It should be less. So I want to do it, and then I want to talk through why. You're confused?
No, I'm good.
Why'd you say I'm confused if you're good?
He said that.
Who's confused?
He said I was confused. But I'm fine.
Are you confused? Well, stop me if you are.
Who's confused?
Why do people keep saying it's totally fine if you're confused, but I want to know.
The situation.
Seriously, what is going on? Well, 10 more scores, take the mean. 10 more scores, take the mean. You guys are like, screw the math. This is cool. There's boxes that are colored. So, here's the thing. What are the chances that one of these blue bars is over here? Like, extremely unlikely, right? Almost impossible. So, here's what that tells you. Is it more likely for one person in the junior class to get a 400? Or, so that's situation A. Think of the odds of like one random person in the junior class getting a 400. which is like just showing up and blindly guessing. But there are some people in the junior class that did and do that, yes. Or, so compare to situation B, I randomly sampled 10 people, and the average of those 10 people comes out to 400. Which one is less likely? Situation B, because now I don't just have to get like one person there, but I basically got to get like 10 people there. Sorry, yeah. So what I was just describing to you is called the central limit theorem. Well, it's in the notes, we'll get to it, but I just want to kind of talk through it. So I can fast forward. You won't get the cool, pretty animation anymore, but I can do like 10,000 at a time, 100,000 at a time. I'm just keep pressing it. So we're up at like 3 million right now. So, is it biased or unbiased? Unbiased, higher or lower variability? Lower, which is what we said, right? Didn't we just talk through the idea that the bigger sample size, the smaller standard deviation there should be? So, that's what's going on there. That's called the central limit theorem. What if it looks like that to start? So, the mean up here is 8.08. Do you think our mean will be that? So do you think it'll be biased or unbiased? Higher or lower variability? I think the variability thing is easier. So this would be like, we have a really poor performing school on the SAT. Like most people are here around like 600, and there are a couple people over here that did really well. So in this situation, how likely is it going to be that I average 10 people together and get like 1,500? Like extremely unlikely, right? So isn't that going to like bring everything back to the middle? So it'll be a lower variability situation. Yeah. Biased or unbiased is hard. How many think it'll be biased? I think it'll be unbiased. So let's look at it. Hold on, let's do 5 because it's faster. I'm going to get bored in a second, just fast forward. But so you can tell already, higher or lower variability. It's a lower standard deviation, right? Like it's packed together tighter. We can't really tell biased or unbiased yet. Let's start fast forwarding. So here's it's not quite there. It actually will turn completely normal if I do this for long enough. If I just keep hitting 1,000, 1,000, 1,000. And you guys can't, I don't know if you can see the numbers, but can you see that? What's the mean up here? 8.08. What's the mean down here? 8.08. So this is one of the things in what's called the central limit theorem, which again is in the notes, which we'll get to. But it doesn't matter what shape the original population is. It makes no difference. So they give me this possibility here. I can do uniform. So like every single SAT score is equally likely. Well, if I start doing this, the mean's going to be the exact same, and it's going to be approximately normal. I can do this custom one where I just make like random bars. So let's say I did like something like that. Well, if I start taking these, the mean's the exact same, and it's approximately normal. So if you take a large enough sample size, the sampling distribution has the same mean as approximately normal. That's called the central limit theorem. I want to try something. I've never done this before. So this may or may not work, but we're going to give it a shot. So we probably won't even take notes today. We're just going to talk. On what?
On the second, variability.
Okay.
But it's like based on this graph, based on what it looked like, just right.
was exactly where the mean was. The means were the same. That 8.08 number.
I was looking at the way the graph was shaped, and I was like, wait, looks more like this.
Alright. I'm trying to explain the same idea here, just in a different way. So what I did was go on a Google Doc, and let's look at the bottom row just because it's easier because I can write stuff down there. And I just, like, the row number is here, so 1 through 29. Every cell in here, I typed in rand between 1, 100. Well, that'll give me a random number between 1 and 100. I repeated that over here. And I found the average of those numbers. So, this is my population. This is the average of those numbers. So what's the label that we would put there? Mu or X bar? So population mean is mu. So this is my population, and I'm talking about the average. So this would be mu in this situation. Well, if I start taking samples of 4, let's say, and it could be any size, but I'm just going to do 4. And then I find we're gonna just like repeat that process that was on the video. So let's do this. Everybody, this is not truly random, but we're gonna pretend it is. Pick 4 numbers between 1 and 15, and then look up. Like if you pick 2, 4, 7, and 8, look up the second number, the 4th number, the 7th number, and the 8th number, and then find the average of those 4 numbers. Let me say that again.
Yes.
So pick 4 numbers randomly as best you can. I know it's impossible, but pick 4 numbers between 1 and 15. And then go to that number column. Like if I picked, let's say I picked 1, 2, 3, 4. I would find the first number, second number, third number, 4 number, and average those 4 together. And then I want you to tell me that number. 1. The average of the 4 that you picked. Where'd you get 3 from? There's no 3 in all. Okay. Oh, gotcha. Okay. You guys get what I'm asking? Might be you'll listen. So, pick 4 random numbers. Do that. Just tell me what they are.
3, 9, 14, 12.
Okay. The fact that you went backwards like freaks me out. So go to the third column, so you pick 53. 9 would be, so 46. 26 and 73 would be your 4 numbers. You see I'm getting those 4 numbers? And then find the average of those 4 numbers and tell me what it is. You got it already? 47? Sure. I don't want the 4 numbers. I want the average of the 4 numbers. Yeah.
Mine's 53.7.
Flat out 51. No decimals. Any others? Is that everybody? What? 42. Okay. So I'm guessing nobody picked 7?
I did.
Really? So you got that 90 in there?
Yeah.
Okay. So now this didn't quite work as well as I hoped, but this is a small sample size, so it's going to be off a little bit. But the biggest thing I want you to notice, what has the bigger standard deviation? The population, like the row that we started with, or the average of our samples? A bigger standard deviation. The row has a much bigger standard deviation, right? Like this is way more spread out. When I start taking averages, that's going to narrow everything. Small, like these numbers, the biggest one in here is 53.75, and the smallest one's 47. Like they're packed pretty tight. The one up here, the biggest one is 90, and the smallest one's 8. So our standard, this is like the blue thing on the bottom is a lot narrower, right? That's the point I'm trying to get across. If this were to work perfectly, which it didn't, but that's okay. That happens. That's part of stats. What would the average of all of these numbers be? It'd be 54.2. It's going to be lower than that because I don't even think we have a number that's above 54.2. These are all below. But do you see the point I'm trying to get across? Okay. I kind of want to do that again because I want it to work better.
I didn't tell. Mine is 56.5.
Well, that helps. This isn't working. Everything's screwed up. Oh, my bad.
I felt weird because mine was the only big one.
So, well, no, the average is 54. You're good. If I took a bigger sample, like if I took 5, would this work better? Like we'd get closer to the average, or worse? I think it's well. Let's find out. Do row 1. Pick the same numbers you picked last time. Whatever you ran, but then add 1. So I want you to pick 5 numbers this time. Average those together. And let me know. You know, if it's convenient for you, Jay. So the true means 46.8. Let's see how close we get when we start averaging averages. You got it. Shut it up.
42. 48. 45.
It's right there. What? That's an example of unbiased.
I'll take it.
You did what?
Like when I added my first one numbers up before I did like the 5 by 4, I got 210, and then I did it again with like the 5, and I got 210.
56.
How the heck?
I don't know what you're saying.
It's not that
It's not important. All right, sorry.
47.8.
Are there more?
Oh, 52.6.
I already have that one. That wasn't yours. That was a different one.
Yeah, me too.
Okay. Okay.
Interesting.
44. I'm missing 1 then, I think. Okay. Now average those. There's 11 of them. There's 11. What is it? No, you don't know. 46.4, basically. The first 46.38.
Yeah.
Do other people get that also?
Yes.
But if you round it like 1, it can be 46.
Right, but it's basically 46.
Based.
Just add like 5 on.
Are you guys getting the same thing as 46.38?
Yes.
Okay, so what we just got was the true average of our population was 46.8. We took a sample and then we averaged a bunch of those samples. And is the shape going to be more or less variable than this one? bigger or smaller standard deviation, more or less spread out. Let's give you like 6 different questions to answer. Sorry. Yeah. So if it's a true unbiased process, and we did a large enough sample size, which we didn't do, the X bar down here would be 46.8. We got X bar was 46.38 and a much narrower distribution. So our process would work if we did it for long enough. If we did like every single possible sample of 5, the average would come out perfect. Nobody does that. That's not a thing that happens. But yeah. So I'm really trying to get 2 points across. Well, 3, I guess. Population versus sample. Just like what's the difference between those? Which is that clear enough? Population is the big group, samples like the sip of soup that you try or whatever. Unbiased means if it's truly unbiased, what would be true about these two numbers? It would be the same. And then variability, so that when I take a sample, what happens to the variability? It gets smaller. Smaller standard deviation. Alright. Give me like, that was like a totally different way that I've ever taught this, so I'm just curious. Like, did it, yeah, how much sense does it make what I'm trying to get across?
The visual?
Visuals, you like the boxes?
No, like that. These.
Give me like 5, 4, 3, 2, 1, like how well you think you understand what I'm trying to get across right now. 5 is good.
I'm gonna say right.
Don't flip me off.
4.68.
Yeah.
Okay. Okay. So tomorrow we'll look at like the notes and the problem. We'll start doing that.
Or to watch the boxes.
Or we can just watch boxes every day.